Ladies and gentlemen, good evening and welcome to Dr. Pluring's electronics laboratory, or whatever it is, caravan electronics off-grid power storage charging from multiple sources into a battery of... I'm trying to figure this out here. So we start by just drawing the thing out. That was annoying that the paper had a little bit of a dog's ear on it, so we take another one. There, little mouse is there too. Yes, hello mouse, how are you doing? I'm doing all right. Great, good for you. Good for you. Right, so I'm planning to build. Try and be somewhat organized here, or something. Yes, I'm planning to build a battery for use in my caravan, right? It will be a lithium iron phosphate battery made up of 8 cells of 160 ampere hours each, and therefore forming a sort of 24 volt system battery. So this will be made up of these 8 cells. 1, 2, 3, 4, 5, 6, 7, 8. It doesn't really matter. And before this, any of this actually goes and talks to the world, it will go through a BMS, a battery management system, like so, which has a positive and a negative. So far, nothing fancy. You haven't gotten that far. No. Well, that's it. So far. We draw out. I haven't quite thought this through before. I've thought some things through beforehand. We have a positive rail, we have a negative rail, say. This is the BMS. And this, we want to charge this from all sorts of places, really. So on the roof of the caravan, there will be solar panels. There, and hopefully the sun might be shining every now and then on them. And they will need a solar charge controller. So they will be hooked up to that one. There you go. We say for now we plan to hook them up in series here, the solar panels, sure. And I have no idea what solar panels are going to get, or the size of them, or anything. I need to someday, when the weather isn't complete utter junk, I'm going to have to get up on the roof here, or at least have a ladder, so I can access the roof and measure. There is all sorts of hatches here, ventilation, what you call it, sunroofs, a television antenna which I may remove. Who watches television nowadays? But that could be a good entry point for cabling from the solar panels, actually, when that is removed. And it has a little chimney, yes, from the heater. Anyway, solar charge controller, which also has a positive and a negative coming out of it. That goes over to the somewhere in the vicinity of the battery as well. There will also be an AC charger to have the possibility to charge this thing from the grid when or if that is available. Right. Oh, and one more thing. If we do a little line, say through there, and we say that this part of the drawing is inside the caravan, and here is the towing vehicle, or the car. Right? The car has an alternator that puts out 14.4 volts or so, say. I already have in the car a thick wire. I think it is all 50 square millimeters, or maybe not, maybe 35, but it's a decently heavy gauge wire going from the alternator, or rather the battery in the engine compartment, to the rear of the vehicle. And in the rear of the vehicle, say that this that comes off here, there will be one of these here old-fashioned style simple relays, voltage relay, voltage sensing relay, or what they're called. I think the voltage sensing relay, right? And for reasons that we'll hopefully be able to explain, I will put another battery here, a regular old lead acid battery. Lead acid, but it goes to the positive, and the negative just goes away to ground here, sort of abstracting away the ground, and so because I'm planning to use chassis ground when it is possible, and so on, both inside the car and inside the caravan. Right. So when on the move, you will want to charge from both the solar panels and the car alternator, the system in the car. And since this will be a 24 volt system and we have a 12 volt system here, I need to step up the voltage. I also need to step up the voltage for a multitude of reasons. One is obviously that this requires a higher voltage, and put 14 volts on this, not a whole lot's going to happen. So from here, there will be a boost converter. That steps up the voltage to something, and that also has a little, will maybe, hopefully, also have a little adjustable, not a relay really, but an adjustable thing on it that tells it under this voltage. When your source here is under this voltage, shut off. Don't step up anymore. Don't push any power through. Just turn off. And why am I having this convoluted thing with another battery in the boot of the car? Because when the engine is running, I might be able to pull like 100. Say that we can pull 100 amps out of the alternator. A lot of that will go to a lot, but a decent chunk of it will go to when initially starting up, topping up the engine battery, or starting battery, and the running of the various vehicle systems and so on. I don't know what we will have left. Say that we have 50 amps left or something, that we can put into here. 50 amps at 12 watts. That's almost half a kilowatt. About half a kilowatt. Not bad. Okay, and then what? Yes, and then here's the thing. Here's the thing. We haven't gotten to the thing quite yet, which I haven't quite figured out. But so far, I think that this is pretty much clear, at least in here in my head, of how I'm supposed to do this. Mouse, you agree? It's clear, right? Pretty clear. Between the towing vehicle and the caravan, there's a cable that you hook up to the car. Well, we know how this works, mate. Sure. Yes, but in that, there's one wire that is supposed to, in the legacy system here, charge the battery and provide power to the so-called refrigerator rubbish thing. I've ordered a compressor fridge, by the way, for this thing. Just now I measured and I found a model that will probably, hopefully, reasonably fit in the compartment where the current refrigerator is sitting. And I also hope that this compressor refrigerator will be a bit lighter than what this is, and I will save a few kilograms there. But anyway, that cable or wire that goes from here, and that goes all the way from here, from the connector to all the way back here, and here is where they bring it inside of the caravan. There's a junction box, goes out to does all the marker lights and brake lights and blinkers and things. But this thick wire is only for charging battery and powering fridge while engine is running. So that goes this way. So that's almost 10 meters long, that cable. And the gauge of it is gauge. I'm probably using the wrong word here, but never mind. The gauge of it, the thickness of the cable is 2.5 square millimeters, which isn't a whole lot, really. It is not a whole lot. But we have that. It goes through the connector. We say that there is a connector here that will be oxidized and have various voltage drops and everything in it. That comes into the caravan, like so. But you have 2.5 square millimeters there. You also have a ground lead here, obviously, which is also 2.5 square millimeters. Yes, but we have more loads than just the fridge and battery here. You have a lot of marker lights. There are say 3, 4, 8 on each side, and I think they are like at least 5 watts each. Should we do a rough guesstimation, just how much power is all the marker lights and everything? Say that we have 8 times 5, so that's 40 watts just for marker lights. And well, that's only on the sides. Yes, then you have 2 marker lights on the back, which are probably 5 volts as well, and you also have 2 marker lights on the front. So that's another 4. That's another 20 watts. At least 60 watts constantly that needs to return through this same ground cable of 2.5 square millimeters. And when you have the brake lights on and the blinkers on and things like that, there will be even more. A bit more. But 60 watts, say, and at 12-ish volts, the 14 more is more of what we'll get, but because the engine will be running and so on, right? So that's just for sake of having something to do. P equals U times I. I'm a little bit slow in the head here this evening. It's late and I've had a straining day of work, so forgive me. 60, 14. So we want to divide 60 by 14 to get the amperage. Right. Just forgive me for a little while I'm going off this tangent here, but that's 4 amps roughly for the marker lights, and maybe we'll fit the other lights in there as well. Problem here then is that for this length of wire, which is almost 10 meters, I've rounded up, hopefully I've rounded up a bit, but with an acceptable voltage drop here, you'd be able to get about 5 amps here. 5 amperes, which isn't a whole lot, at least not at 14 volts. At 14 volts, that's rubbish. But the boost converter could put this up to like a lot more. Well, you still want to keep it sort of safe-ish. So say a maximum of like 50 volts or something. If we did that 50 volts, but that's one alternative, to step it up as much as possible. But if that length of wire that we have, which is 10 meters and 2.5 square millimeters, if that is sort of like 5 amps with an acceptable voltage drops in singular, voltage drop, still, you'd have to deduct the 4 amps from the marker lights. You're going to have quite a bit of voltage drop here anyway. Yes. This is hopeless, maybe. But never mind if it is hopeless or not. That's not really the point here that I'm trying to figure out right now. This will probably, I'll find some solution for this that will be acceptable for all the electronics and so on. And it doesn't matter that much if there's a bit of voltage drop. But we don't want to overheat the ground wire going back. But then also the ground wire, would think, I haven't looked very closely at this, but I would think that terminates here in the junction box and is just connected to the chassis here. I would think. I see no reason why they would pull it all the way up here. Maybe they do, maybe not. Because the chassis is ground here. I measured in the connector the voltage pin, or the ground pin. Between ground pin and chassis there is continuity. But in any case, just for the sake of argument, we try and bring all these voltages here to something that would be close to what this should want to charge, which I get to be around 29.2 volts. Sort of, but here we get into a bit more, and here we get to the crux of the matter, and where I feel like I have been misled, I've not been misled, but I've misunderstood a significant concept here. And this battery management system, as it is called, that should rather be called a battery protection system. Because a battery management system, I would assume and have assumed that would be able to control the charge, for example, going into the cells. But reading through this manual, it seems that it doesn't quite do that. It has protection modes. For example, it can turn off the charging if the voltage is too high, or if the amperage or current exceeds a set limit, or so on. It can go into protection mode and disable charging and disable flow of current through to the cells, and also the other way, discharging it. But my understanding was that it would you'd be able to supply a reasonable voltage here, and this thing would help you or help you get that power into your cells. But now, not quite, mate, because you have to do this yourself. And if I only had the solar charge controller, that already has all these settings in it. Like, this is what you're supposed to do for charging, and when the battery reaches this voltage, then you're supposed to bring it back, bring the voltage down a bit, and stop. And you do for these lithium iron phosphate cells, you want to do is constant current and then constant voltage charge. So you regulate during the first part of the charging, where you're supplying a constant current. You're regulating the voltage to get the current that you want, and when the current when your voltage here rises to a certain point, you switch to doing constant voltage, and thereby also limiting the current, I think, from your charger into the battery. But I would need some sort of combination thing here, because as I had it in my head, I would just be able to connect all these things together, have all these things set to a reasonable voltage somewhere around 29.2 volts, which is the voltage of this battery if it is fully charged, or rather not fully charged, fully charged, and also all the cells are at their max rated voltage, which is 3.65 volts. And resting, or what you'd say, I know that these terms aren't quite right for lithium cells, but they're a bit inherited from the lead acid days. It would be about 27.6 volts for a fully charged battery. And then in between, when in the usable spectrum, or what you'd say, of the battery, the discharge or the charge curve is like this. So if you have voltage, it goes, and state of charge here, it goes pretty much like this. That's more or less your voltage curve for your lithium iron phosphate cells. It's not quite this flat, but almost. And when you reach 2.5 here, you stop discharging it, and when you reach 3.65 here, you stop charging it. But in between here, that's only the last few percent there, and in between it's pretty much the same voltage, more or less. But yeah, I really thought that this would do that, but that doesn't do it. It should not be called a battery management system. It should be called a battery protection system, because that's all it does. It protects the battery from overcharging or undercharging, or rather discharging it too much. But so if I put a limit in here to say only put this amount of current in, if the current goes above that, what this will do is it will disconnect. Or rather disconnect, it will stop current flowing through these here MOSFETs, and thereby stopping charging of the battery. And then it will wait for a while and apply charging back and see what happens. And if it still is in an overcurrent, over a specified current, then it will stop again. And same thing for voltage. It won't really regulate the voltage and current going into the battery for you, if I understand this thing correctly. So it's a battery protection system is what it is. It's not a battery management system at all. So what I need here, the solar charge controller will have settings for which voltages it can put out, but it won't really help me a whole lot. And my AC charger, whatever that will be, that I will have to establish some sort of voltage coming out of that. And here, either I step up the voltage to what I need here in the car, or I step it up to a lot more than I need here, and then I have a buck converter to bring the voltage down to a reasonable level before putting it in here. But still, there is something missing here. There is one component missing, and that is some sort of charging combination thingamajig that will combine these various power sources and put that at a voltage, regulate both current and voltage going into the battery when all these things are available. All these things will never be available at the same time, because you won't have AC power as you're towing. I mean, I suppose you could sit idling the car with the AC power cord hooked up, but you won't do that. So only two of these will be available, and solar will be available at least during the day. And depending on the day, you might get a lot, you might get basically nothing. Right. But for here, if I can do 5 amps, if I do that at 50 volts, I'm going to use the calculator, because my brain is not functioning properly. So 50 times 5, that's 250 watts. It's not a whole lot now, is it? Because the battery has a usable capacity of almost 4 kilowatt hours. That's going to take fucking forever to do at 250 watts now, isn't it? Yeah, that's going to take forever. That's the reason I have the lead acid battery here also, because that I'll be able to dump a lot of power into that, and also the way the lead acid batteries work, and the way the car alternator is designed to work. It's designed to work with lead acid batteries. It's what they do. So I can dump all the power available from the alternator into the lead acid battery, and I can do that at the rate that the alternator can do it, and that's, as we established before here, almost about half a kilowatt maybe. Then the battery might not be able to accept power at that rate for a very long term or a long while, but never mind. Still, I'll dump that in there, and when the car shuts off, in a short while, this voltage relay will realize that the voltage here has now dropped below my thing, and it will disconnect, and this thing will continue discharging this lead acid battery through the boost converter through the cabling and the connector and everything to the buck converter, which will convert it down again to a voltage, whatever the voltage will be here, going into this magic charging box, which must have the intelligence to read the battery voltage, know if it's supposed to do constant current or constant voltage, and so on and so on and so forth. Right. And in either case, what we must feed this reasonably, the voltage that we must feed it here must be greater reasonably than what it should ever be expected to feed into the battery, and I don't think that should ever exceed 29.2 volts, because that's 3.65 times 8. So for sake of something, just putting a number here, we say that we do 30 volts, have a little bit of headroom. 30 volts. Okay, so that's where I am currently with this. I sort of have this figured out. I at least have ideas of how to do this, an AC charger for it, and I sort of have ideas of how to do this. This is pretty clear, actually. This I could build now. I need to rewire the connector here a bit. That shouldn't be too difficult, because it goes to a little junction box which is right in the boot. That shouldn't be too difficult to hook up something that can go to the Caravan. But this is a question mark for a reason. That's because I don't know what that will be. Hopefully there is not an overpriced product available that can do this, or one can cobble together a solution from various reasonably priced and easy to use building blocks, and then you have your thing. Right, I think that's it for now here regarding charging off the battery. I will we'll be back soon, or in a random time, sometime, with a little, just looking a little bit closer at the properties of this here battery that I'm going to build, and what properties it will have in forms of how fast you can charge it, how fast you can discharge it, what power that actually entails, and so on. So there you go. Thank you so very much for watching, ladies and gentlemen. That will be it from here, from Dr. Pluring's electronics Caravan off-grid battery manufacturing and electrical systems charging laboratorium. Good night.